Recording and so I hope you have been able to practice some more problems that we discussed last week. So if somebody is willing to present some of their solutions, they are welcome to present. Right after some time, I would now request Sai Pranav to solve some more problems. With Sai Pranav, we also have Viraj Marathe who will help us in solving more problems. So over to you, Sai Pranav.
Hi. So we'll start doing a few problems first. So we're pretty much continuing where we left off last time, which has been Bhaskara problems. So is everybody here?
Yes.
Okay. So Bela's mom brought a present and locked it inside the safe. She gave Bela a blue ball and said, "You can have the gift if you solve the puzzle and get the key that is in the middlemost drawer." So the drawer in the middle, which is to open the drawer, Bella must put an object of the correct shape in the key hole of the drawer. Then the drawer pops open and she can get the object which is shown on the front of the drawer and lies in the drawer. So basically, the key is whatever is written on the top of each drawer. And when you put the key inside, whatever is on the bottom over here is given out. So if I put in a star over here, I would get back a crescent moon. Is everybody understanding?
Yeah.
So at the start, you have a blue ball, and the question is, from all of these options, which drawer should you go through to get the key in the middle so you can unlock the safe? So to solve this, one method is that we can just check each option and see what it does. So the first option says to get a pentagon out of the blue ball, and we can get a pentagon in the blue ball. Then we can put the pentagon into the use the pentagon to get an upside down triangle is what it says, which you can do over here. Then the first option says to get a heart with the triangle, and then to get a diamond shape using the heart. So this is what the first option says, but you can't unlock the middle drawer because you need a moon. So that's why the first option doesn't work. And that is the same for the second option, because it doesn't end in a moon. You can't get a moon with that. So you can't use either the first or the second options. So that immediately rules them both out. Now, if you look at the third option, it says again to get a pentagon first, then exchange the pentagon for another upside down triangle, then exchange the upside down triangle for a star, and exchange the star for a moon. So this works, and that way you get a crescent moon, which you can use to unlock the middle drawer and get the key. So is everybody understanding?
Yes.
Yeah. So that's why the correct answer is C. Okay. So now let's go to the next question. So Anne and Bob put 4 bowling pins in a row besides each other. On their turn, they can either drop a single pin or 2 adjacent pins in one shot. They can always choose which pins to knock down. Whoever drops the last pin wins. Both Anne and Bob can ensure their victory if they always choose well. The question is, considering that Anne plays first, which pin or pins should she drop from the following options to ensure her victory? So should she drop the first pin, the first 2 pins, the middle one over here, or these 2 pins so that she wins? Now for this, we can slowly go through all the options. If you go look at the first option, if she does this, then what Bob can drop this pin out from here, and then Anne will either have to pick this pin or this pin. And whichever she picks, only one pin will be left, which Bob can choose, and that way Bob will always win. Is everybody understanding?
Yeah.
So then in the second option, if she drops the first two, Bob can just drop both of them instantly and then win. So then in the third option, Bob can drop this middle pin, and then Anne will either have to again pick this pin or this pin, and then Bob will clear out the remaining one and win. But if you look at option D, Bob has to choose either this pin or this pin, and then Anne can just choose the other one and win. So that's why D is the correct answer. Everybody understanding?
Yeah.
Okay. So now we'll move on to one more complex question, and then we'll do the simple ones again. So the question is that Beaver Emil is trying a new puzzle on his computer. He has to arrange a stack of marbles in a cylinder. The rules are that the marble must be either red or blue. There must be at least. Can everybody see my screen right now?
We can't see that screen. I don't think we can.
You're on the original screen.
Oh,
Yeah.
no, just try resharing. Can you see it now?
Yes.
Okay. So the question is, Beaver Emil is trying a new puzzle on his computer. He has to arrange a stack of marbles in a cylinder. The rules are that the marbles must be either red or blue in color. And there must be at least 3 marbles in the cylinder at the start. Okay. And every time, at every round, whenever the go button is clicked, the lower 2 marbles are let out. Then one of the two things happens depending on the color of the first marble of the 2 that drops down. If the first marble that drops down is red in color, then at the top, a new blue marble will enter the cylinder. So when the go button is, let's say, pressed over here, these 2 will fall. And because of these 2 falling, red is on the bottom, one blue will come at the top. And if the first marble that drops is blue, then 3 marbles will come in at the top. Is 1 red, 1 blue, and 1 red. Everybody understanding?
Yes.
Okay. So then, if at least 3 marbles remain at the press of each go button, then the go button will be pressed again. And the game ends if 2 marbles or less remain in the cylinder. And the stack shown on the right over here, this one, will is a game that will end in 5 clicks. At this point, only 2 blue marbles will remain in the cylinder. So the question is to produce a starting stack that consists of only 3 marbles, which will produce a never-ending game. So then, to do this, basically all that you need to do is make sure that the bottom is a blue. Now that is so that if the bottom is a blue, then immediately 3 marbles will be dropped in at the top. So now let's just take any random example as a red, and blue. So then once the blue and red at the bottom drop down, then at the top you'll have a red, a blue, and a red drop in from the top. Now next, 2 reds will fall, which will create 1 blue at the top. Now there'll be only 1 blue at the top, so then currently there'll be blue, red, blue. Then next, the blue and red will drop. So that way, again, a red, a blue, and a red will come on top. So then this will keep repeating, and it basically becomes like an infinite cycle. So as long as you have blue on the bottom, the game will be never ending. So is everybody understanding so far?
Yeah.
Okay. So now I'll give it over to Viraj, and he'll do some of the smaller problems again.
Hello guys, I hope you can hear me. Okay, so now the question is, spotted cuckoo birds don't build nests. Instead, they move into empty nests. So when it finds a nest, these birds, it repeats some steps to find a good nest for it to rest in. So first, it will go up until it encounters a nest. So after that, if the nest is empty, it will directly occupy it and we move on to the next cuckoo bird. But if the nest is occupied, it looks at the dots on the cuckoo bird's head. So these dots, these. So if the cuckoo bird has more spots on its head than the other cuckoo bird that's trying to go, then it will move to the left. Or else if it has the same number of fewer, then it will go to the right. So this is a tree which has 5 empty nests and there are 5 cuckoo birds. The birds move into the emptiness in order from the left to the right. So from the one with 4 spots is the first one. So the question is which bird will move into the highest nest? So let's see. First, the first cuckoo bird, which is the 4 dotted one, will go in. Now here, it will just stop at the lowest nest. Now, so the next one, which is this one, it will go here and it will check. The nest is occupied. So the cuckoo bird inside has more spots. So this bird will move to the left and now it will occupy this nest. Now the third bird, which is this, it will go here, move to the left, and here it has the second bird has fewer spots than the third bird. So this bird will move to the right and taking and the rest in the highest nest. So the answer is D, the one with three dots. Is everybody understanding till now?
Yeah.
So we'll move into the next question, which is arranging shapes. Rinki the Beaver is playing with a shapes board game. The board is divided into squares. Initially, she placed the shapes in each square like this. Then she swapped the pairs of shapes, that is, made the two shapes exchange their positions. She made four swaps in this order. So first, we'll look at the question. What will be the position of this shape after the last swap? Which is this one. So now, in this question, Rinki is first taking the star and moving it to the triangle's place and taking the triangle to the star's place. So in this way, the yellow triangle is now on the third column of the second row. From here, it moves on. Then the red star comes to the yellow triangle's place and the yellow triangles take this place. Now here from the red star comes the green circle. So the green circle is here and in the green circle's position comes the pink's shape. So now the answer is this. third column of the second row, which will be C. So is everybody understanding?
Yeah.
Okay. So another faster way to do this question is to, because we are swapping the positions of these shapes, we can directly look at the first shape which is being swapped, which is the green star, and the last shape. So the position of this will be the position of the green star at the beginning. So the answer will be C. So does everybody understand this matter also?
Yeah.
So now we'll do a complex. Yeah, now one of the complex questions, cards and cones. Ines has a pack of cards. Each card has a number written on it from 1 to 9. This pack contains many of these same cards. She places 3 colored cones in front of her, named A, B, C, and she intends to create stacks under the cones with the numbers facing up. Each time she puts a new card, it will cover the rest of the stack. Her friend Jules takes the notes as she puts the cards one at a time. So she starts by placing a card under the 5 on the red cone. So her friend writes A under A 5. So it's written as which number goes under which cone. So here it's the 5 number card under the A cone. Similarly, she will put another card which is 3 under the A cone, which will then cover the whole stack and only show 3 on as the facing number of that cone. She can also see the number which is facing up, so in this case 3, and take the same card number and put it under B. Now, after the whole process, the Jules final notes look like this. So starting with the first one, is everybody understanding till now?
Yeah.
So starting with the first one, and puts a card number 5 under the A cone, which is the red cone. She then puts a 3 number card under A. Now she puts the first card number that she sees of A into B, which will be the previous number, which is 3. So, okay. So now we'll just make A, B, and C. Here we have 5, which was the first one, then 3. Now in B, we have added the previous number which was there in A, which is right now 3. So now we'll add a 3 here. Now after that, a 3 is again added to the B cone, which is the blue cone. So here we'll add another 3. After this, the previous card number of B was added to A, which will be 3 again. So now we'll add a 3 in A under the A cone. Now under the B cone, a card number of 5 was added. Then after that, under the A cone, a card number of 6 was added. Now we have the C cone. The C cone, the card in facing card of the B cone was added, which will be currently 5. So we'll add a 5 here. And again, A cone will add the facing card of B cone, which is 5, to the A cone. So write a 5 here. Now we have added another card number, which is 1, under the B cone. So now question is, what cards are visible when the cones are lifted, which is the facing card of that cone? So we'll write the correct numbers. So the answer is 5, You have to write the latest number or the previous card, which is 5, 1, and 5. So the answer is 515. Is everybody understanding this?
Yeah.
Another faster way to do this is just looking from the bottom. So here we already know that the last one is B. So this answer will be 1. And A and C are just the face values of B previously, which will be 5. So we directly get the answer as 515. This is another faster way and a more complex way to solve this. Is everybody getting this one also?
Yes.
So has anybody prepared any other problems that they want to solve? If you want, you can solve any other problem if you have prepared it. Okay then, so we'll go back to the simpler problems now. Does anybody want to solve this problem? Like try solving it? Does anybody want to try solving the problem on screen right now? Okay. Okay. So the question is that raster images, which is a type of image, consist of small dots called pixels. Each pixel represents a certain color. For example, in a black and white picture, each pixel is either black or white. To avoid wasting disk space while saving pictures, a compression method applies. An example of saving a picture of letter A, this one, and is employed over here. The first number in each row relates to the amount of white pixels at the beginning of the row. If the first pixel is black, the row begins with a 0. So now it is divided into rows, and then the first row is written over here as 1, 3, 1 because it has 1 white, then 3 black, and then 1 white. Everybody understand it?
Yeah.
So then for the second row, it becomes 4 white and then 1 black. Then this row is 1 white, then 4 black. Now this row starts with a 0 because it starts with a black. You have to say 0 white at the start. So it becomes 0, then 1 black, then 3 white, and then 1 black. So that is how the raster image storing mechanism works. So the question is, from this, which of the following images is made? Does anybody want to try solving it? Then you can just try if you want to. Okay, so first it says 15. So we can start trying to imagine what it is. So it will be 15 white. So that is true for all of these so far. Okay. Then the next is 5 white, it says. So wait, we'll just zoom into this image. So we have 15 white on all of them over here. All of them only have white on the top row. So that is correct. Then next it says 5 white. So you can see 1, 2, 3, 4, 5. Then 3 black, 1, 2, 3. And then 7 white, 1, 2, 3, 4, 5, 6, 7. But if you look at the second B option, that is false because it starts with a black. So therefore it cannot be B. Is everybody understanding?
Yeah.
Yeah.
So then this is also true for C and same for D. So it is all true, the second row. Now if you see the third, fourth, and the third, fourth, and the third and fourth rows are same for all A, C, and D. So we don't have to check the third and fourth rows. So we don't have to check this one or this one. They both are same for A, C, and D. So we can directly go to the fourth one, which is 2. which is 2 white, 1 black, 7 white, 1, 2, 3, 4, 5, 6, 7, 1 black.
I think it
then
would be.
4.
I think maybe we can just go for the fifth one before the fourth one.
What, the 5th
No.
row?
Yeah.
No, D.
Yeah, we can also try that, I suppose. But it is more better to make sure directly from the 4th one. Because you can also see that D doesn't match the 4th one. So that way you can easily eliminate D directly.
Yeah, but I think if we do the fifth one, you can eliminate 2 at a time.
Yeah, I suppose that will also work, but it will be a bit more complicated. If you want, you can do it.
Okay.
Because
Thank
in that way, you don't even have to check like the above ones. You can just directly check the middle 5th one.
Yeah, true.
Okay. So then if you look at the 5th row, it says 1, 1, then 4. Now that's false for A. So we eliminate A. And then the only one remaining is C. So that's why the answer is C. Is everybody understanding why?
Yeah.
Okay. So, wait. Hmm. Wait. Does anybody want to try solving this problem? Avni, Dhruv, Avnish, anyone want to try solving it?
I'll try. It's fine. I'll try.
Okay.
You just give me some time because like right now my Wi-Fi is a bit down. So just let me connect to a new one, please.
Yeah, okay, it's fine. We'll wait a bit for you.
Can you hear me? Can you hear me now?
Yeah, we can hear you clearly.
Okay. You like very much to design necklaces from beads with various shapes, and you would like to easily share your design with your friends using a compact representation. Each shape is described with a single bead letter: S for a star, T for a triangle, R for a rectangle, and L for a line. Instead of writing down the sequence of beads in the necklace, you use the following rules. The rules are: if these are several identical beads following each other, just write the number of beads followed by the bead letter. If there is a repeating sequence of beads, just write the number of repetitions followed by the repeated sequence in parentheses. Otherwise, just write the bead letter. For example, for the following necklace, the star, triangle, the rectangle, then Sai Pranav, my internet is down, so I don't think I can explain it because it keeps on fluctuating. I just had to exit it by mistake. So
It's all right, it's fine. I'll continue the problem then. So for the following example of necklace, this one, it will be written as first S for the star, and then since there is a triangle, then rectangle, but this is repeated 3 times, so we can put the triangle, rectangle in bracket and then say 3 other star. So it will become star, then 3 triangle, rectangle, then it will become 3 stars because there's 3 stars, and then 1 line. So it will become S, 3TR, 3S, and L. Is everybody understanding? Okay, so then the question is, how many symbols are required for the shortest representation of this necklace? So a symbol will be counted as either a digit, a letter, or a parenthesis. So now let's start doing it. So first you'll say star, so S. Then there are two rectangles, so wait. S. Then two rectangles. Can everybody see where I'm typing it right now?
Yeah, I can see it.
Okay. So then you have one so then after the two rectangles, it'll become S, 2R. Okay, I'll just write it again. It is S, 2R. Yeah. Then after S2R, we have one triangle, so T. Then after that, we have 4 stars, so 4S. Then after 4S, we have a cycle of a rectangle star, which occurs twice. So then we'll say 2, and then in parentheses, triangle star. It's what you could do. Or another way to do this is, instead of doing instead of doing 4 stars at the start, we just do 3 stars and then use 1 star to make another pattern which will come with these 3. So you have 3 star triangle. Is everybody understanding that? So instead of doing 4 stars, then we'll have to do a triangle star twice and then 1 triangle separately. Instead, what we can do is say 3 stars and then say a star triangle 3 times. Okay. So yeah. Now if we so it will be so then we'll continue. Which wait, the text just got deleted. 1 second. I'll rewrite it.
Wow. Yes.
Yeah. So now we'll do only 3 stars and then 3 in parentheses star triangle. Yeah. Then at the end we just have 4 lines, so we'll say 4L. Everybody understanding? Okay, so now we'll count the number of symbols will become 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the answer is B. Is everybody understanding? Yeah. Yeah, okay, so that's it for today. Then yeah. Does anybody want to try solving any other problems? Call one of them. Okay. So we'll do a which is okay. So Dhruv, do you want to try solving this problem? Dhruv, Avnish, anybody else to try solving?
Yeah, I can try it.
Yeah, okay, just try solving the problem.
Beavers and Beavers, Anna, Bella, and Lena made necklaces according to their names. To represent each letter, they agreed on a way to thread beads, heart, and diamond. Also, they agreed to separate the letters in the necklace with beads circle. Which necklace did Lena make? So, if we see Bella's name, I think what we have to do in this sum is we have to see which letters are common with the other names. So, Lena first has L, and Bella has L in the third and fourth letter. So L is heart, diamond, heart, heart. Then so it can be option A or option D. The second letter for both is the same. Only the third letter is different. Third letter is an N, and Anna has N. N seems to be diamond heart, and that is there in the first option. So it's option A.
Yeah. Okay. So, yeah. So now Viraj is going to explain one more problem.
Okay, so the question is find a mistake. Sunita has written a program to guide the beaver to its home. The program consisted of these 5 commands. The first command is correct and guides the beaver to move like this. However, there is a mistake in one of the next 4 commands in the program. Now the question is, which of them is a mistake? So now let's check. So we'll start with the first one, which is move to the front, which is correct, right? So now after that we have to up. So now we reach here 1 and 2. After this, she's telling the beaver to go right 5 times. So let's count it 1, 2, 3, 4, and 5. Now we go till here 5. So now is everybody understanding till here?
Yes.
Okay. So now next it is she's telling us to go 4 up, which if we do this, it will take us on the land. So the problem is the 5 right command, because it actually needs to move 6 right so that it does not interfere with the land and can directly go from here. So now if we do that, it will go 2 here, so 2 up, right, it will go 6 times, which will be 1, 2, 3, 4, 5, and 6, and then it will move 4 up 4 times, so 1, 2, 3, and 4, and move right once to reach its home. So the answer to this question is B. Has everybody understood?
Yes.
So the next question is moving the ball. Viewers are playing a game of moving a ball in a cylinder. The goal of the game is to classify the same balls to the same cylinder. The rules of this game are as follows. The first rule is the ball cannot be moved into another cylinder with no ball. If when there is a space in the cylinder, the ball can only be moved on a ball of the same color in another cylinder. And rule 3, only one ball at the top of the cylinder can be moved at one step. So, if we want to win the game as below, how many steps do we need? So now we'll just see the examples here. So here, we have the rule 1 and rule 3. So this
Means that by following you can move only one.
by following rule number 3, we know that we can only move this one ball, which is at the top of the cylinder. Now, following rule 1, we can move it to the cylinder with no ball. So here, the red ball goes to the third cylinder. Now, following rule 2, if there is a space in the cylinder, the ball can only be moved on a ball of the same color. So the green ball from the first cylinder moves to the green ball on top of the second cylinder. And following rule 2 and rule 3, only one ball can be swapped. So we'll take this, and rule 2, which states that if there is a space, you can only keep it on top of the same color. Now, has everybody understood these rules? So the question is, if we want to win the game as below, how many steps do we need to move the ball? How many steps do you need to move the ball? Least. So firstly, we can move any of these here. So if we move this one, we'll move this to the third cylinder, which is following rule 1. So now we'll just make a diagram here. Green. So now the green is here, and red. These are the reds, and another green. So now after this, we can move this red ball to this. We can move this red ball to on top of this, because this green ball is in cylinder 3. So from cylinder 2, we can move this here. So just clear this and here. So now we will have two red and one green here, one green here, and one green here. So now we will move this green here, which this one, this green on top of this green, which is already there in third cylinder, which is this one. So now if we move this here, we will get this. We will get this diagram. So we will have two. We'll two red, one red here, which is just one green here, and two green here. So now what we can do is move these two red directly towards this. Now this will be counted as two moves, because only one ball can be moved at a time. So these two moves, we will take both of these red balls and put them here. So after this, the final piece is this. This one is remaining in the first cylinder, and we can just bring it here. So this will be six steps needed to complete this whole to move the balls least. Has everybody understood this?
Okay, so does anybody else want to try solving any other problems, or else we're done for today? Okay, so next time try to solve some problems beforehand then.
Thanks, Sai Pranav and Viraj for conducting the session. Any doubts? Somebody has any doubts or suggestions for improvement? Teachers, do you have any suggestions? Nausil sir, Sonal teacher, any suggestions?